Hello everyone, my name is Arya Devdhar and this is part 7 of NCERT Class 10 Science, Chapter 9, Light, Reflection and Refraction. Okay, so in the last part, we completed the entire chapter, the concepts of the whole chapter. So we ended with the sign convention and lens formula, magnification and the power of the lens, right? So in this part, we are going to see some PYQs of this topic. So mainly we are going to see numericals, right? So PYQs, numericals. Usually from this topic, numericals itself come, like there are no theory questions, not many theory questions. So PYQs, numericals of this chapter. I have tried to select as many different varieties as I could so that you can get an idea of what comes in the board. So these numericals I have taken from the previous, like this year, so 2024's board papers, different sets. So let's see them one by one. Okay, so let's start. Okay, so let's start with question one. Yeah. So question one says that a student took three concave mirrors of different focal lengths and performed the experiment to see the image formation by placing an object at different distances with these mirrors as shown in the following table. Okay, so a table is given, three cases are given. All the focal lengths are different and all the object distances are also different. Okay, so let's start one by one. A, list two properties of the image formed in case 1. Okay, two properties of the image formed in case 1. So see, in case 1, if you notice, the object distance u, it is given 45 centimeter, right? And the focal length, it is given 20 centimeter. So that means if focal length is 20, that means the center of curvature will lie at 40. So that means object will lie beyond C, right? So if object is beyond C, then that means that the image will be formed between C and F, correct? And the image will be real and inverted, okay? And it will be diminished. The ray diagram I'll show you in rough here, okay? So you'll get an idea. The ray diagram will be somewhat like this. If this is your focus, this is your center of curvature, object, and your image will be formed here. Okay, if you remember the ray diagrams, then you'll understand this. This is the second ray diagram, right? Okay, so list two properties of the image formed in case 1. So out of these three, you can write any two. Real and inverted, between C and F, and diminished. So this is basically position, size, and image, nature, right? Okay, now second. In which one of the following cases given in the table, the mirror will form real images of same size and why? Okay, so when does the mirror form real images? So there is only one case, right? The case where the object is kept at C, right? So here the object will be kept at C and then the image will also be formed at C. If you remember, it is the third case in concave mirror image formation, right? And the image formed, it is of the same size as the object, but it is real and inverted. So now in the given cases, in which of the following is the object kept at the center of curvature, that you have to check, right? So basically object distance should be double the focal length. Am I right? Right? So in the second case, if you notice, the focal length is 15 and the object distance is 30 centimeter. Correct? So it is double. That means object is kept at center of curvature. The image formed will be real and of the same size. So hence the answer will be case 2. The object is at C and hence the image will be at C and it will be of the same size. Correct? Now moving on. C, the first one. Name the type of mirror used by dentists. Give reasons why they use such type of mirrors. So I'd explained at the time of uses of concave mirrors, right? So concave mirrors are used by dentists. The reason for this is concave mirrors produce virtual and magnified images. Okay, so in the sixth case, if you remember, the virtual and magnified image is formed, right? So the dentists use such mirrors to magnify the teeth so that they could get a clear view, right? So hence that is the reason. So concave mirror is used by dentists due to first magnified and second virtual and erect image. Right? If you remember, in convex mirror, we also get virtual image, but in convex mirror, the image is diminished in both the cases. Here, the image is magnified as well as virtual. So both the points are very necessary in the answer. Right? Okay. Now the OR question for C. So look at the table and identify the situation, object distance, and focal length which resembles the situation in which concave mirrors are used as shaving mirrors. So again, the same thing. Dentists use concave mirrors. Shaving mirrors are also concave mirrors. The same reason, because they form virtual and magnified image, right? So we have to see in which of the situation the mirror is used as a shaving mirror. So basically that means that the object, it should be kept here, right, between P and F, right? So we have to check that the object distance, it should be less than the focal length. So in which of the following cases, let's see. Case 1, no. Case 2, also no. See case 3. Case 3, focal length is 30, object distance is 20. So 20 is less than 30, right? So in case 3, it will be used as a shaving mirror, okay? So as you can see, where U is less than F, that is object between focus and pole. So therefore case 3, right? And the array diagram I have not drawn here, but the one which you have to draw, I'll just give you a rough idea. Right, so if this is your object, then this will be your image formed, right? Due to tracing back of the rays. Am I right? Okay, so that is the ray diagram which you have to draw in this question. Understood? Okay, moving on. Next question. So it says, define the following terms in the context of a diverging mirror. Okay, so I've not written it here, but I'll explain it to you. I hope you can write it down. Okay, so the first thing which you have to clear out is what is a diverging mirror. A diverging mirror is a convex mirror, right? If you remember, a diverging mirror is a convex mirror. Now, define principal focus regarding convex mirror. So, basically, principal focus, it is a point on the principal axis from where the parallel rays to the principal axis, they appear to diverge from. Or you can also write as the rays parallel to the principal axis, they appear to diverge from a point on the principal axis, which is known as the principal focus. Understood? Okay, and the second one, focal length, easy. The distance between the principal focus and the pole of the mirror is known as the focal length. And you can also add one more point, that the focal length of a convex mirror is positive, right? It is on this side, no? I'm sorry. It's on this side, right? The focus. So it is positive. Correct? Okay. Now draw a labeled ray diagram to illustrate your answer. What you will do? The ray diagram you'll draw is this one. Parallel rays, right? This is the focus, and the rays appear to diverge. The rays appear to diverge from the principal focus. This diagram you will draw. Correct? Understood? Okay. Now let's move on to the numerical part here, the B part, right? So an object of height 10 centimeter is placed 25 centimeter away from the optical center of a converging lens of focal length 15 centimeter. Calculate the image distance and height of the image formed. Very simple question, okay? Just formula based. So you have to understand the information given though, right? So here, as you can see, height of object is given 10 centimeter, right? Now a converging lens is given. A converging lens is basically convex lens, right? So a convex lens is given and its focal length is given 15 centimeter. Now if you remember, the focal length of a convex lens is positive, right? So hence plus 15 centimeter, and U is always negative in all cases. U, that is object distance, is given 25, so it will be minus 25 centimeter. Now what we have to find? We have to find V, that is image distance, and height of image, HI. Right? So solution by lens formula, we will use the lens formula. Okay, see the green part. 1 by F is equal to 1 by V minus 1 by U. Substituting the values, 1 by 15 is equal to 1 by V minus 1 by minus 25. So minus minus will become plus. So 1 by 15 is equal to 1 by V plus 1 by 25, right? 1 by v is equal to 1 by 15 minus 1 by 25. The LCM will be 75. 15 5s are minus 25 3s are 5 minus 3 is 2. 1 by v is equal to 2 by 75. V is equal to 75 by 2, that is 37.5. So you got the answer of V, image distance, that is 37.5. Okay. Now the second question asked is HI. For HI we have to use the magnification formula, right? That is M is equal to HI by H naught. HI by HO, V is equal to V by U. So that is these two cases, right? So HI we have to find upon 10 is equal to 75 by 2. So you can put 37.5, but it would become lengthy. So instead just put the fraction part, right? So 75 by 2 upon minus 25 with sign. Remember, always with sign, right? So if you reduce this down, you'll get the final answer as minus 15 centimeter. Okay, the final answer will be minus 15 centimeter. So you have found both the things. Now, for the final statement, you have to write both of them in like statement form. So that is the image distance or the distance of the image from the pole of the mirror is from the optical center of the lens is 37.5 centimeter, right? And also the height of the image is 15 centimeter, correct? You can also add that the image is real and inverted because the height of image is negative, right? So it is from below the principal axis, hence it is real and it is inverted. Simple. Now we'll move on to the 31st question here, which says the power of a lens is plus 4 diopter. Find the focal length of the lens. Now, an object is placed at distance of 50 centimeter from the optical center of this lens. State the nature and magnification of the image formed by the lens and also draw a ray diagram to justify your answer. Okay, easy, again easy question for 3 marks. Let's see. Okay, the power is given plus 4 diopter. So by the power formula, P is equal to 1 by F. So 4 is equal to 1 by F. F is equal to 1 by 4, which is equal to 0.5 meters. Okay, meters. Always remember P is equal to 1 by F in meters. Okay, so we have to convert it to centimeter, 25 centimeter, correct? Into 100. Okay, now come over here. The object distance is given 50 centimeter. Okay, and here first of all, the focal length is positive, right? And it is a lens. So that means the lens is a converging lens or convex lens, right? So just keep that in mind for now. It is a convex lens. Okay. Now the U is given minus 50 centimeter. That is 50 centimeter from the lens. Always negative. F is 25 centimeter. So first we have to find out V. Actually, they have asked the nature and magnification, right? So, but for magnification, we don't have the height of the image or the height of the object. Hence, we have to find out V first. Okay, so that's what we are doing by using lens formula. 1 by F is equal to 1 by V minus 1 by U. 1 by 25 is equal to 1 by V minus 1 by minus 50. So, I've directly written it plus 1 by 50. Right? So, 1 by V is equal to 1 by 25 minus 1 by 50. So the final answer we get as 1 by 50. That is V is 50 centimeter. So image distance is 50 centimeter. Understood? Now we'll calculate the magnification, right? I'll write this. Magnification. So M is equal to V by U, right? Which is equal to 50 divided by minus 50, which is minus 1. So M is basically minus 1, right? So what does this indicate? The minus sign indicates that the image is real and inverted, right? The image is real and inverted. The minus 1, the 1, it indicates that the image is of the same size, right? The magnification is 1, it is of the same size. And also you can write that it is 50 centimeter away from the lens. From this, V is equal to 50 centimeter. So you got all the properties, you got the nature and also the magnification of the image formed by the lens. And they have also asked you to draw the ray diagram to justify your answer. So the ray diagram you will draw, it will be like this one. Okay, so the object will be kept at 2f1 and the image, it will be formed at 2f2 and of the same size. Understood? Take care. Okay, now let's move on to the next question. Yeah, the next question is an easy one. It's an MCQ type. Okay, again asked in the board 2024. right? An object is placed in front of a convex mirror at infinity. According to the new Cartesian sign convention, the sign of the focal length and sign of the image distance in this case are respectively. Okay, so the object, it is a convex mirror first of all, right? The object is kept at infinity, right? Parallel rays are thrown on the mirror, and we can see that it gets diverged from the focus. So that means the image is formed at the focus. First of all, the focal length of convex mirror is always positive, right? The focus is on the right side. And image distance here is also positive because the image is formed at the focus itself, right? So the answer will be D plus plus. They only want the sign, correct? Understood? Okay. Now moving on. A light ray enters from medium A to medium B as shown in the figure. Okay, so in the figure we have two mediums and a light ray. Okay. Now let's answer the question. Which one of the two media is denser with respect to the other medium? Justify your answer. Okay. So basically, if you notice, from medium A to medium B, the ray is bending towards the normal, right? So if you can see like this, it is like this, right? So this angle, it is greater than this angle, right? So hence it is bending towards the normal. Understood? From A to B, ray is bending towards the normal, right? Also, velocity, it is inversely proportional to the optical density. Velocity is inversely proportional. That basically what I mean to say. For example, you have glass and you have air. We know that glass is denser than air. Okay, we just want to verify this. So also we know that the speed in air is highest. So air is rarer, but the speed in air is highest. So basically that means that the velocity of air is more, but the density is less. Right? So that indicates that velocity is inversely proportional to optical density. Okay. So hence we can say that B, it is denser than A because the ray is bending towards the normal when it goes from A to B. Simple. B is denser than A. Now the B question, B subpart. If the speed of light in medium A is VA and in medium B it is VB, what is the refractive index of B with respect to A? Okay, so we have learnt the formula mu12 is equal to V2 upon V1. Right? For velocity it is ulta. For mu it is the same thing, mu1 upon mu2, but for velocity it is V2 upon V1. Right? So here they have asked refractive index of B with respect to A, right? So BA is equal to VA upon VB. Hence, so that's basically the answer, right? So it is mu BA is equal to VA upon VB. Now the OR question. A ray of light starting from diamond is incident on the interface separating diamond and water. Draw a labeled ray diagram to show the refraction of light in this case. Sorry. Okay. So you know that diamond is denser than water, right? So the ray will bend away from the normal, correct? The velocity of the ray will increase in water. Okay, so the labeled ray diagram basically means that you have to show the arrows, you have to show the normal, and you have to label it. This is the incident ray, right? Full time pass. This is the refracted ray. Refracted ray. You have to write diamond water. You can also write here denser medium, denser and rarer. Right? You can write this is the normal. This is the angle of incidence, angle of I'm sorry. Yeah, angle of refraction. Correct? So all this is basically labeled ray diagram. Understood? Simple. Okay. Now B. Absolute refractive indices of diamond and water are 2.42 and 1.33 respectively. Find the value of refractive index of water with respect to diamond. Again, the same formula will be used here. So firstly given mu D is equal to 2.42, mu W is equal to 1.44, diamond and water. Now we know that mu of 1 with respect to 2 is mu of 1 upon mu of 2. So mu of water with respect to diamond will be mu of water upon mu of diamond. So that is 1.33 upon 2.42. So if you calculate that, you get the answer as 0.54, or you can round that off to 0.55 as well. Okay, understood? Okay, easy. Okay. The reason because 0.55, because after 0.54 you get something 8 or 9. Okay, so you can round it off to 0.55 as well, or you can keep it as 0.44. No problem. Okay. Okay, so in this way, we have completed the chapter Light, Reflection, and Refraction. If you have any doubt, feel free to ask me in the comments, or you can leave me a mail at the mentioned email address in the description. Again, I will be leaving the link of these question banks, right, of these papers in the description. So do check that out if you are interested. So that's it for today. Thank you so much.